More launching, more rockets. That's the power of X. Space X. Or something. I don't know. I don't know. It's a banger, though. You guys want to hear another banger? X Depot. The everything store. Don't get any funny ideas, Elon. Anyway, alright, here. You have a one more song to listen to. That was purposely off key. This wasn't, though.
Apple bottom jeans. Boots with the fur. Whole club looked at her. Baggy sweatpants and Reeboks with the straps. Gave that big booty a smack. $1,000,000 vibe bottle to go. The birthday cakes, they stole the show. Next thing you know, Shorty got along. Shorty got along. Shorty got along. She got along. Shorty got along.
Discovery, go at throttle up.
Remember, Paganini was a composer. Pavarotti was the singer. Okay? You're imagining Scott Manley singing that. What? Okay. All right. Hey, Force, 82 months. Public, what did you say? You said something. I'm at KSC. What should I see? I'm on the bus tour. Take the extended tour and go see the Saturn V. You're welcome. Calm sonar. Crazy Ivan. Way to go, Dallas! Yeah. All right. All right. Well, we got a Starliner press conference at 2, so I should probably change that title up. Change the Space News to 2 and go from there. But in the meantime, let's fire up Kerbal. Burble. Hooded, how are you? How's everybody doing? Might not be a good one. Boeing aims to have Starliner ready for its first flight to the ISS with astronauts on board around next March, a timeline that hinges on a parachute drop test around November, among other factors. We'll see. We will see. Did you see the AI parody of Louis Armstrong's apple bottom jeans? Boots with the fur. The whole club, they was looking at her. Shorty got low. Did you know, Blue, that song has ruined Wonderful World by Louis Armstrong? That remix of it? It ruined it.
Discovery,
It completely
go at throttle
ruined
up.
it. And did you know, at my wedding, you do like first dance with your bride and stuff, right? And then, you know, there's dances with your parents and stuff, and my mom chose that song. Not the apple bottom jeans version. And it ruined it. I was like, I can't do this. It's like, what a wonderful world. And I'm like, oh no. Keep it together. Keep it together. Keep it together. Keep it together. Oh no. And my mom's like, oh, don't be emotional. I'm like, I'm like, you don't understand. It was awful. No, it was fun. It was fun. I love you, Mom. But also, she's like, oh, I'm like, I'm not crying. I'm not. Does your mother know about the apple bottom jeans version? No, I don't think so. I didn't. I was like, yep, that's what's going on. I'm being emotional right now. That's what's happening. Oh boy. It was weird. It was weird. All right. Anyway, Kerbal time. Yes, we saw you giggling the whole time. Yeah, I know. It's just. What do you do now? No, nothing. I'll see you tomorrow in class, Miss Vaughn. You blew it. Okay. All right. Where are we? Here we go.
Discovery, go and throttle up.
Okay. Hey, Hattie. This is 21-monther. Robert Parker? Oh, well. Kerbal. Here you go. This is definitely a Friday night song, not a Monday morning song. No, just I had some personal stuff pop up yesterday. I didn't have time. You just need to check in that something is working? Oh, alright. There's your ad time. No ad? Oh, good, perfect. Look at it. Look at it, chat. Isn't it marvelous? Does it fly? No. No, not yet. Yeah, it doesn't get very far without any wings.
Discovery, go and throttle up.
Hicks! What's up, buddy? 69 months. Nice. What happened to the wing measurements? They're right here. I had frozen. I don't know what you're talking about. I didn't buy that astronaut dealing and handing out an Apollo cap shuttle clip pen. It was a tad expensive. Oh, that's okay.
Discovery, go and throttle up.
Hey, Neat. What's up, buddy? 101 months, dude. 101 months. How'd you guys like the NSF cast yesterday? Pretty good? Did your boy do okay? It seems some of my explanations YouTube chat didn't like. But, hey, I'm trying, man. I did okay. Closing in on 154. That's right. You did good. Thank you. You're a natural. It appears my explanation of things have caused some controversy. Yeah, there was some stuff they didn't like. Not NASA spaceflight. Some people in the YouTube chat. Are you curbled yet? Ah! What's up, man? Dude, I got you hooked on Vice-Grip Garage. It's like the old kill rep. It's roadkill, but 10 times big. It is, isn't it? It is sequels, isn't it? Derek's the freaking man, dude. Yeah, just reminds me of the old roadkill episodes, dude. I don't know what to tell you. This is the best channel ever. I watch Vice-Grip every Friday. Every Friday after the stream. Cow flow rates. cow gaseous flow rate, or CFR. You know how many tabs I have open? Oh boy. Sequels. The first Vice-Grip video I watched was the it was Independence. That was the first one I watched. Can you imagine? I got that as a treat for the first watch, and I'm like, whoa, this guy's the man. And the lightning whirler. That's right. Seriously, Derek, that guy taught me a lot about how old cars work. Like, a lot about old cars, dude. Like, watching him, dude, I can fix whatever now. Like, combined with whatever the hell else is floating up in here. Oh, we can fix whatever. Easy peasy. And I hate admitting this. I kind of like wiring. I like wiring cars. Wiring is fun. Which is odd because everybody hates it. I don't know how to feel about that. I don't think I'm doing something right. Blink twice if wiring has your sanity at gunpoint. No, everything's good. I'm looking forward to you working on the Chevy. Well, we might, yeah, that project's coming, but there might be more. I got a Carcane problem. You mean digicals? I mean digicals. I do. Yeah, I don't mind the wiring. Okay, all right. Anybody here an IT nutcase? Cable management in your computer? Like getting all the cables, like routing all the cables? Dude, you could do that with cars. And it looks just as good. Have you failed miraculously while wiring yet? Chow Dubs, I failed miraculously well on stream while wiring the 59. I wired... I think I wired coil positive to the voltage regulator by accident and fried a voltage regulator. And then I didn't even realize that I fried a voltage regulator until 2 days before my wedding, a couple of years later. Yeah, that's good. Yeah. Yeah. My private PCs are a mess while my workplace setups are immaculate. Yeah, I fried a voltage regulator on stream. I didn't even know that I did it. Yeah. Yep. Oops. Whoops. There it is. Yeah, no, I've failed miraculously. I've failed plenty of times working on cars on stream. So whatever, it's how you learn. A little tired and a little wired. Yeah. Do we have that VOD? No. But dude, yeah, I can get whatever running now. It's pretty sweet. Like, it's like you hit this threshold of suffering while working on cars enough that you've suffered enough that everything makes sense. Does that make sense? If it didn't make sense to you, you need to work on cars more. Am I right? Am I right? If you know, you know. Building a skill 101. Oh God. Yep. Hey, that's Kerbal. That's learning, dude. You're gonna fail a lot. But you're gonna fail a lot and it's gonna hurt, but that makes winning even better. Yup! Brake cleaner down the carb. Use gasoline. Use gasoline in a bottle, man. The brake cleaner can detonate. Another thing I learned from Derek. The suffering doesn't end. I don't know what you're talking about. Well, I do it for fun, Sawyer. You do it for a job, so. Sawyer, I told you I got all the trim for the F-250, right? All the interior trim, which was long gone when I got the truck. Yeah, it's got a complete dash. Everything is complete. All the vents are brand new, new glove box. Everything is complete except for the damn ashtray. I didn't get to do my nightly routine of falling asleep to YouTube videos last night. I had some personal stuff that I had to deal with. It's just family business, you understand? The complete Chad, we're just talking about some family business that we needed to get done. Buonasera, Chad. Buonasera. Buonasera. You come to me on the Monday of the stream, asking for subscriptions and bits. You broke my heart, Chad. You broke my heart. I know it was you. You broke my heart. Fredo. What? Sorry, I had something stuck in my throat. Have you watched Grand Tour yet? There's a new Grand Tour? Yeah? No. Remember the Rat Rod Supra? Oh yeah, that thing was cool. You can pass as Italian? I would hope so. I would hope so, considering... I mean, look, see? Look. Look at the Italian part. There's the American part. See what I'm talking about? See what I mean? Look at that. Either that or I'm from Idaho. I'm not from Idaho. See what I'm talking about? Look at this. This is nice. This is nice, beautiful tan color, and then you just... Ah! Yeah. No! Look at this. Look at these. You put some jewelry on here. You say, hey, look at this. Look at my father's rings. Look at all this. This is worth at least $350. Okay. All right. Are we ready to roll? So, and how often do you go outside? I touch grass every weekend, drummer. Actually, having 2 days off is pretty sweet. I mean, I didn't do it this weekend, but having 2 days off back to back, it allows me to kind of refocus, and I think it makes the weekly streams better. Dude, drummer, like, here's the thing. I have to touch grass, man. I got a lot of it. A big backyard. There's a lot of grass to cut. Yeah. A lot of grass to cut. When EJ showed his bicep, I thought I got flashbanged. I mean, my lawn's mostly crabgrass at this point, but the crabgrass filled in where all the dead grass was, so my lawn looks pretty good right now. It looks pretty good, man. It's looking pretty good. You know, chicken skin diet's really working out for you. Green is green. Yeah, dude, we're good. I cycle to work every day. Checkmate. No car? Drummer, I own 5 automobiles. No, you can't have one. Buy your own damn car. Lots of grass. Does Boston have snakes? Yeah, garden snakes. No car? Netherlands here, baby. We don't need cars. Yeah, Animal, that's the difference. I don't need cars either. I want them. See what I'm talking about? Carcane issue. You're like, All right. 1, 2, 3, 4, 5. Nah, Driver, I'm just kidding. Cycling to work's probably good for you. I would cycle to work too, but it's not that far of a commute. How's the design going? Sile, it's going good. Sile, you're in luck today, my friend. We have a Starliner press conference at 2, so you will get your early space news. Mate, you're gonna get your early space news, innit? You're gonna get your early space news, mate. Everyone with a car key. I don't need it. I don't need it. I definitely don't need it. I need it! T-Man, great coverage yesterday? Well, thank you. I appreciate it. I was trying, guys. I was really... Contrary to this whole stream, I was trying to be professional. I really... You know, like... okay, a more professional version of me. Not this. This... You know what I mean? I heard that Super Heavy static fired yesterday. Yeah, it was fun.
Discovery, go and throttle up.
Hey, Jake. 31 months. Just bolo for copperheads. I don't think we get copperheads around here. You got to worry about coyotes. We have coyotes around here. And if you call them coyotes, people are going to look at you weird. I blame you. I blame the people that from the Midwest that watch the stream. You did this. I like Fago now because of Brimo. What the hell? What the hell's that about? I'm wondering why they cut the duration. Conservative parameters, dude. Most likely. Don't you put that evil on us. She is fixing you. Yeah, well, she moved here, so... No, guys, all right, here. I hate to reference it again, but here's a peace offering. See? There's your, you know what I'm talking about. You know what I'm talking about. All right. Flashbang through the door! Sprint to the finish! I'll see your 5 cars to flying a plane that looks just like Concorde. It may or may not be a twin otter. Oh, very nice. Yeah, okay. Comment about how she should let you guys move to Florida. Nah, I'm good here. I'm too much of a mass holder to move to Florida. Oh well. Alright. Are we ready to roll? We gotta work on the tessellation today. I forgot, why did you abandon cylinder tanks? You can get more fuel in for the volume here with the Mark IIIs.
Discovery, go and throttle up.
I like this tank design. I'm not sure how it's gonna work with Aero, but we can definitely see. Hey, Creeper, what's up, dude? That's tier 2 at 50. Thanks, man. Thanks for the support, dudes. I appreciate it. And dudettes. We can't forget our lovely ladies that watch the stream in the chat. That's what I was trying to say. Are you planning on how to make the wings? Last time you said you had an idea. Yeah. Cinnamon, I have something. But we're gonna have to see. Put Fat 455s on temporarily. Tessa, I'm pretty dang confident that if I make a tessellated wing here, it's going to work. The center of mass center lift is going to be so funky on this thing. Now, I don't think so, Hellfish. If you take a look, the tanks are relatively symmetrical in Star Raker's design. I did this on purpose. I'd have to go look at the fuel tank design on the real one, but if you notice, the tanks are all lined up right on where the cargo bay and the fuel tanks meet. They're basically lined up on the COM. So we're more or less we'll get a symmetrical fuel drain here. More or less. But it is coming together, dudes. I actually dig it. I think it's really, really cool looking. Are you clipping them as bilobe tanks? Slightly. The clipped volume right here literally is that volume. We figured that out. We know that from prior. So as long as I don't put anything here, it basically mimics the bilobe tank design that's in the real one. Oh. Oh, still have that up.
9, 8, 7, 6, 5, 4, 3, 2, 1.
I can't believe they streamed it, dude. Hey, Antares. It was kind of frustrating to watch, though. New Deluge seemed to work just fine. Think it'll reach orbit next launch? Yeah, I mean, Murdoch, if they get to staging, I think, like, not to parrot Elon, but if they get to staging, that's going to be a monumental achievement. Are you adding fuel into the remaining parts of the wing? Well, in real life, they did have that there, so yeah, we'll see. I hope it reaches orbit next time. It would be cool to see a starship in space, you know. I guess they wanted a public win as opposed to what many in the public perceived as a failure. Can you imagine Star Raker and the shuttle working together? I mean, yeah. Yeah. Yeah, I can. I know it wasn't, but people are dumb. Yeah, I don't know what to tell you, homie. It's KSP Do Dead. That's one for the day. 24 minutes into the stream. That's one for the day. No, Generic. It's just being patched. Give it some time. We'll visit it again when they patch the game. In the meantime, I just, wanted to do some crazy stuff in Kerbal 1, dude. It's cooking. Let the devs cook. Yep. You'll try and keep count today? Okay. If Star Raker didn't work, would they have still used the shuttle? I mean, they were really designed for different missions, Kick. It's possible. Like a good marinara or bolognese. Takes time. Yep. Marinara. On the weekends, Hellfish, my dad just cooked sauce. I'm like, what are you making the sauce for? He's like, what? I'm like, what are you making the sauce for? He goes, I don't know. Just making sauce, man. Leave me alone. I'm like, all right. That's fair. I don't question it. Been there before. Hey, good sauce takes time. You're right. You're absolutely 100% correct. You want to make a good sauce, it has to be done right. This isn't just empty the ragu can and throw it in the pot. All right? There's more to it than that. Chad, you capiche? You understand? There's a lot more to it than just that. Nice. Nice. Kevin and Jim Days may have central and northern Iowa covered, but southern Iowa is where I'm from. It's something else. It's a big slice of nothing, but it's my big slice of nothing. It's a good way of looking at it, Aquilus, yeah. It's not harping on ragu, but yeah, that's interesting to know. I always prefer the sauce with some pasta in it. Ando, the sauce that my dad makes, I'll have to show you guys it sometime. We gotta do some type of cooking stream or something at some point. The sauce that my dad makes is so tasty. You can just take bread, like take a sub, like a hoagie or just a piece of Italian bread, cut it down the center, fill it with sauce, and eat it. It's delicious. You put some cheese on it, like literally meat. It's like having a meatball sub, because the way my dad makes it, he puts meat in the sauce, so it's meat sauce. So it's literally just a ground up meatball sub. It's frigging delicious. There, I said it. Not ashamed. You've done that, haven't you? Of course. Never let good sauce go to waste, man. Ever. I can't stand it at like Italian restaurants, and they bring you a big old bowl of marinara for something. And like for your appetizer, like if you have breadsticks, they give you marinara, right? And then they're like, "Can I take the marinara?" I'm like, "No, I need that." And they're like, "What?" I'm like, "I need that. I need that for my pasta for later." And they're like, "Oh, okay, that's weird, but all right." I'm like, no, you cannot take that half full bowl of marinara off the table. You can't do that. Do not do that. Do not touch the sauce, okay? I don't think you understood me, son. Give me all of your bacon. Twist, there you go. So, at the end of the meal, even if there's sauce on the table, I'm embarrassed telling you this, but whatever. Even if there's sauce on the table, can I have another breadstick? But breadsticks are appetite. Can I have another bread? Oh, yeah, sure. So dip the sauce, right? Sauce. Dude, can't let the sauce go to waste. What's wrong with you? Okay, wing tessellation. I'm getting upset about this, man. I don't take the sauce. No, absolutely not. Look, I'm Italian. I'm a food snob. What do you want? Like, I don't know what you want. I don't know what you want from me. All right, so, chat, you gonna learn about wing tessellation today, okay? Don't touch the damn sauce. Leave it on the damn table. All right. So, what's wing tessellation and how does it work? Wing tessellation is using these triangular wings in the game to make surfaces, right? To make a complicated surface, all right? The last batch of sauce I made has homegrown celery, garlic, tomato, and herbs in it. Bellissimo. Bellissimo. Amico. Very good. A bad food snob? Yeah. Yeah. Italian, man, what do you want? What do you want? Like, I don't know what to tell you, right? Okay, so this is how wing tessellation works. We could basically use a bunch of these wings to make a complicated shape. I'll just give you a quick example. Now, you've probably seen me do this before if you were here for the shuttle build. If not, let me show you how we make wings like this. Let me show you. Let us show you! Sorry. I made a vegan cheese sauce yesterday from potato, carrot, and spices. Vegan? Your Pacific Northwest is showing. Was it good? I mean... You ain't got no knees in that sauce? No bolognese in that sauce? You call this a sandwich? You got no bacon on it? Yeah, it's alright. Okay. I made a PB&J the other day. Oh, Steve, yes. Good for you. Good for you. Did you cut the crust off? Said cheese from carrot and potato. I mean, carrots and potatoes I don't have a problem with. But, I mean, if you want to hit that copium and call that cheese, oh, Force, that's on you. That's on you, man. No, seriously. Hey, eat what you want, dude. I don't care. Just because I'm a food snob doesn't mean everybody else has to be. You know what I'm saying? Jack with the bacon. T-Man, Jack and I are becoming very fast friends. Yeah, we're... I like Jack. Jack's a funny guy, man. Alright, so... That being said, I'll never give up your cheese. The pushy vegan thing from Cat. No, I don't... Oglex, I don't harp on vegans. You can eat whatever you want, homie. Like, I know what you mean. I know what you mean. One of my buddies that watches the stream is vegan, so it doesn't really bother me. I'm just like the only thing with my buddy is I'm like, you gotta have protein, man. You gotta get like soy milk or something. You need protein. Not eating meat is not good for you. Not eating meat. You need protein, right? You need to like take creatine or something. That's the only thing I'm like worried about. Like you gotta have protein. Your body needs protein. That's not good for it if you don't do that. No joke, combination makes it kind of taste like smoky cheese. I mean, first, I don't hate potatoes and I don't hate carrots. In fact, I love potatoes. Chalk that one up to living in Boston. I love potatoes. Can eat potatoes all day. Isn't B12 an issue? Depends on your diet, man. It depends on your diet. Everybody's different, you know? But hey, it's all good. Are we beginning the wings? Yeah. I prefer pasta over potatoes unless it's baked potatoes. It's fair. I'm just playing around here. So with wing tessellation, like I said, you can use this to make complicated shapes. So we're gonna need to start with some control curves here to explain this right. I think my favorite duo is Chris B and you. I'm not worthy, man. Hey, 12 years as a vegetarian, I was D1 shot putter in university with 1,000-pound combined power total. Protein is important, but it's easy to supplement. Yeah, Western culture has an obsession with protein, especially with meat, but it's not that serious. I never said you have to bulk up, doctor, but yeah. And D1 shot put, good for you. How far did you throw? That's cool, man. Yeah, you just gotta have protein. You don't need to bulk up, right? Like, your body just needs protein just like everything else. You gotta supplement it. That's I'm saying exactly what you're saying, or at least attempting to. Probably not doing it very well. Thank you. 51 and change. Bro, 51, dude. You're a tank. That's awesome. I shot put it in high school, dude. I didn't throw 51, man. But I was like the weird shot putter because I did high jump, long jump, triple, 100, 110, 100 and 110. So, shot putting for me was strange, but you know. 51. You're a freaking unit, dude. That's awesome. Good for you. That's not easy throwing that thing that far. 37 mastodons. Hey, new kid, what's up? Ooh, look at that thing. That's nice, RJ. Sweet. All right. The interesting thing, guys, is that I'm looking at the wing shape, and we might not need wing tessellation as much as we think. Hey, Rocket Guy. If you decided to go into the NFL, what position would suit you best? Tight end. That's what I played in high school. Yeah. Ah, very nice, Hellfish. So you're more of a mixed athlete? Did you go for the heptathlon? I probably could have, Tessa, but I probably could have done like decathlon and stuff, but I'd rather play video games. It wasn't high on my priorities list. And that's a shame. That's a shame. That's one thing I kind of regret from high school, not participating more in sports. But, yeah. I mean, my parents are both sports nuts, so they made me play sports. I had to. Like, they were like, you were playing sports, there's no questions. So I played baseball, I played basketball, American football, track and field. I got recruited for lacrosse, but I never played it. Yeah, I got recruited for lacrosse. I didn't do that. I was like, I want to play video games. Piss off. Oops. And I never played hockey. That's a shame, because I love hockey. I just realized that I like hockey after college. Yeah, no, I'm really happy my parents made me play sports. I love sports. Sports. It's never too late. I'm good. Hockey's awesome. What a great sport. Do you like motorsports? Yes. Sports ball! Actually, you guys see Tom Anderson get clocked the other day, speaking of sports ball? You see that? Ramirez? They went UFC right in the middle of the field. He cold cocked him right in the face. That was awesome. That was an excellent fight, dude. Oh my goodness. You like muscle cars? Considering big price, that's in my garage. Yeah, I'd say I do. Yeah, that's my garage. Here. Watch. This here be magic. It's an F100. Yep, that's right. F100 single cab short box. Step side. It's CG! Yeah, you're probably right. Nice green screen. Wish you could have played football in college, but well, it's pretty good at high school level. There's no way it could have been competitive at the Ohio State. I mean, it's Big Ten, dude. Yeah. You gotta be freaking good. It's got a 302 in it, big price. Yeah, 302 C4. C4 automatic transmission. It's got a 9-inch rear end running 370s because the rear end's from the 50s. It's a 9-inch with 370s. Okay. It's open, though. I just finished building it, dude. It was off the road for 10 years because streaming took over my life. Yeah, it's your fault, Chad. Sure. Automatic. It's a cruiser, Tessa. What? It's actually orange screen. 9-inch in the rear. You've been having too much potato and carrot cheese, though, for us. You got a 9-inch full floater for your car. Nice. What was your job before streaming? I worked on a loading dock hand, doing logistics work and unloading and loading trucks for Best Buy. Yeah. I know. Can you up it to a 10-inch? A 10-inch rear end? No, T-Man. No. The F-250 has a 10-inch rear end. Little bit on differentials in trucks. The inches refers to the ring gear in the differential. So in a diff, you have... In a differential, you have a pinion gear and you have a ring gear. And then you have spider gears. All right, so let's look at this diagram of a 9-inch rear end here. West Coast differentials. Here we go. Let's go. So power gets inputted right here through this piece right there. It's on a U-joint, which is like a gimbal on a rocket engine. That's a universal joint. That's called your pinion yoke. Your pinion yoke has a lot of seals. We replaced that one on stream. That one right there, number 10. And then we set the preload by sending it with 3 Ugga-Duggas, which probably wasn't smart, but hey, whatever. And then the pinion yoke is attached to your pinion gear. Pinion gear and shaft. All right, shaft. It's a spline shaft that goes to the pinion. The pinion interfaces with number 3 right here, the ring gear. That's where the rear end inch comes from. It's the diameter of the ring gear. A heavier duty rear end will have a bigger ring gear, but that doesn't necessarily mean that like it takes more power. All right, bigger trucks usually have a bigger ring gear. So my F-250 has a 10.25 ring gear. It's a Sterling 1025 rear axle. Okay, the light duty truck, the F-100, has a 9-inch rear end in it. The 9-inch ring gear is good for cars and trucks, like light-duty trucks. It's not a heavy-duty rear end. But the funny thing is that a 9-inch rear end can be built to be a heavy-duty rear end if you really want it to. There are 9.5 and 10-inch ring gear sets that fit 9-inch cases, but that might just be for aftermarket. Careful, you can hurt your back working a job like that. Dropping a follow-up before I head back to work. Not often someone is familiar with shot put. I have to make my way back. I think you missed my last message, but yeah, 55 foot 1 inch in high school. You do 55 with a 12 in high school? I would ask what the hell are you eating, but good for you, man. Plants, though. For what it's worth, I like eating plants. Plants are good. I like my meat, but plants. You know what? You know what the thing is, decency? Before you get back to work, plants fill you up. That's the thing. They fill you up. That feeling, you know what I'm talking about. Plants do that. All day. All day. That's beast mode, dude. But yeah, no, I got you, man. Hell yeah. Thanks for the follow. I appreciate it. I do like more mechanical and aerospace stuff here. But, yeah. Want to talk shot put? I'll talk shot put, man. I still remember how to do it. It's been years. You know? You have a Holly on the top? Nah, big price. It's got an Edelbrock 1405, 650 CFM carb. It's over-carbed a little bit. Just a smidge. It's too much carb for a 302. It's got a 302 from a 79 F100 in it. So the heads and cam are mid. We'll say the heads and cam are mid-tier and call it a day. Decided to jump back in and see what you work on next. Oh, you got gifted a sub. Right on. Hell yeah. There you go. All right, Doc. Thanks for popping in, dude. Have fun at work, I guess. I mean, that's cool, dude. Freaking tank. Proform 600 CFM carb. I don't know why I need to replace the carburetor that already works, Hellfish, but alright. What dream motor would you put in the F100? 7.3. I would take a Ford's new 7.3 and carb it and put it in the truck. Because big block. Because big block LS. Yeah. Bigger carb equals more air equals supercharger. Yeah. LS swap. You know what the thing is, big price? I don't mind LS's. I'm a Ford guy. I don't know if you could tell. I don't mind Chevys. I really don't. LS engines are very, very cool. But the thing is, dude, is that, you know, you get aftermarket tuning, good heads and a good cam, and you put like a Terminator on whatever, you can make power. You can make, like, we're at a point where computer-controlled systems can make any engine make a ton of power. Like, We could build that 302 and make it have just as much power as an LS for not that much comparatively, like to the price of an LS nowadays. Like, I don't hate LSs, I really don't, but also we could put a 4-liter Jeep engine in that thing and make some power with it if we really wanted to. Rob Dom putting a rotary in the Corvette. Big M, you know what the funny thing about that is? In the 70s, for the C4 or C3 or C4 Corvette, I forget which one, in the early 70s, Chevy wanted to put a rotary in the Corvette. So putting a rotary in a Corvette isn't the, like, debauchery that people make it out to be. It's not. Duntov, the guy that designed the damn Corvette, wanted to put a rotary in it. Sora Duntov, the Corvette's chief engineer, he wanted to put a rotary in it in the 70s, but Chevy vetoed it. Are all the tanks attached to the core? They're attached to the central spine, Hypersonic. Yeah, see, I have an SRB spine here using DAS conduits. And then we also have a mass simulator for the payload. What is a rotary engine? Oh, ooh. Rotary engine, or a Wankel engine, is a type of internal combustion engine that Mazda puts on their cars. There's a YouTuber named Rob Dom, and he's obsessed with rotary engines. Dude, he, like, takes rotary engines and makes, like, prototypes. He has, like, a whole fab shop that makes prototype Wankel engines. So, a Wankel engine does essentially what, you know, piston up and downy motor does, right? Like a standard 4-stroke, but they... Here. Look. It's... The slang term for it is a spinning Dorito. Look at that. Fun fact, on the 13B, that Mazda engine that I just showed you, there's a... See where A is right there? The points, the 3 points of the rotor? They use what's called an apex seal, and the apex seal is made out of Inconel. It's rockets, dude. It's rocket grade because you need to make a seal right there. If you don't make a seal, the engine doesn't work. Yeah, really, really smart. Because this thing has such a short stroke. Long story short, A and B don't get that far away from each other. The rotary engine has very low moment of inertia, so you can rev to the end of time. The rotary engines can go like above 10,000 RPM, no problem. Could like contrast that with a piston motor that goes up and down and up and down and up and down. When you're at high revs, the connecting rod is pulling that piston back and then pushing it forward and then pulling that piston back and then pushing it forward and pulling it back. That's the momentum of the piston is hard to stop and then make go in the other direction, right? The Wankel doesn't have to worry about that. It's just so you can rev them to the end of time. Isn't this part 4? I think part 4 was the other day. It's either part 5 or part 4. Didn't World War I airplanes use rotary engines? No. No. That's a radial engine. Radial engine is also with pistons, but instead of the pistons being in an inline shape or a V shape, they're in a star pattern. Pretty cool, huh? You have 2 part 3s because your OBS crashed. Oh, okay. Yeah, that's right, I remember. No, they did not use rotary in World War I. Different type of rotary, though. They did use a rotary engine. It's a different type of rotary engine. So, question, chat. These rotary engines, were they that? Please. Tell them that they know already. Yeah. These are called radial engines. They didn't call them radials. They called them rotaries. But there you go. No and no. Okay. All right. Well, time to learn something then. Let's see what Mama has to say on the subject. All right, let's take a look-see. Electro, I see it. Yes and no, because the crank was bolted to the airframe, not the prop and cylinders. That's your technicality? That's the technicality. Boom, told you. No. You're making a fool of yourself. You're making a fool of yourself. I mean, it rotates. It does. Those are still called rotary engines. The Waco came long after that. I never... Oh my god. Wow, you guys suck. I'm just gonna go outright and say it. You guys suck. I never said that it did. You guys... Oh, you should rewind this conversation. Wow. Wow! You should rewind this conversation. You freaking making a fool of yourself. You're making a fool. Congratulations, you just played yourself. Can you explain how the transition from turbojet to ramjet works? Yeah, sure, if you want.
Throttle up.
I don't know. I don't know. Is chat gonna come up with something called a jet ram and say that's not what that is? I mean, let me know. It's not a ramjet. It's a jet ram. New gateway render? No, okay, all right. Joking aside, I see what you guys are saying. Yeah, the heads move. The heads and the cylinders move on a rotary engine, but that's not a modern rotary Wankel engine. They're also called rotaries, but they're called Wankel engines. That by technicality, like that, it's a Wankel engine because a German engineer Wankel made it, right? I think it was German. But everybody calls those rotaries nowadays. But also, they also called the spinny boy rotary as well. I get it. But also, I never said that Wankels were used in World War II. You guys did, and then proceeded to try and prove me wrong about something that I already said. I was agreeing with you. That's what I mean about this conversation. You're trying to prove me wrong for agreeing with you.
Discovery, go and throttle up.
It's a turbojet ram. Okay, anyway. This is very counterintuitive. It makes my head hurt. Please stop. Alright, so turbo ramjets. I actually had the page open because I may or may not have been reading about this while I was off mic on the NSF cast yesterday while I was taking a break. And I was reading about the YF-12, which is a very interesting plane, if I do say so myself. Ren, thanks for gifting that sub. I appreciate it. Alright. Yeah, see? I was reading about the YF-12, which is funny. They made the YF-12 to make people think that the A-12 was not a reconnaissance plane and an instead it was an interceptor. And they made that to cover. Like, they're like, oh, look, see? There's the interceptor variant. And they gave it, like, mounts for missiles and stuff, which is... I hosted the NSF cast yesterday. Actually, I was there as a technical expert. Well, I wouldn't call myself a technical expert. I was just there to provide additional commentary. Let's say that. Yeah, the A-12 was made as a, or the YF-12. I was reading about this thing because at the end of the stream the other day, we were looking at the YF-12 that's at Wright-Patterson with the XB-70 next to it, and I'm like, why does it have the cut strake, and why is the cockpit so far out of the... I never noticed the difference, to be honest with you, but it turns out that they made tons of variants of the A-12. The A-12 was the original plane, and out of that came, like, the YF-12, the M-12, the Mothership 12, there was just the straight A-12, and then the SR-71, and then there were 3 variants of the SR-71 on top of that. I don't know why I never bothered to go and look at this, like, because the A-12 and the SR-71 are not the same plane. They look very, very similar, but if we want to go that full, like, well, technically, they are not the same plane. No, very different. Yeah, the mothership. Dude, the M12 is nuts, actually. Pretty maids all in a row. Hell yeah. Oh, now that's a view. So the M12 was a carrier. It was a mothership. Look, or the M21, not the. I got the numbers backwards. Excuse me. Check that out. Yeah, pretty crazy, right? Will this forever be the coolest looking plane? I don't think it gets cooler looking than an SR-71 or an A-12 or the M21. Like, yeah, they wanted to make hypersonic drones, Phil. Yeah. Well, high supersonic drones, right? So basically they'd launch this uncrewed and it would take pictures and then it would land somewhere else. Yeah. Turns out that jettisoning something when you're going Mach 3 is not smart. Yeah, that doesn't work very well. I forget if the M21. I forget, dude. I honestly don't remember. I don't know if it's a variant of the SR-71, but dude, there's all different variants of this thing. It's kind of nuts, dude. YF-12, M21, the A-12, SR-71 A, B, and C, which is strange. Yeah, and they all had different. Yeah, see, the YF-12, the Interceptor variant, has this cut version. I'm not sure why they cut the strake there. I'm sure in this. I didn't read enough of this because I had to go back, but. What is this? Hold on. Oh, it's 26 minutes. Oh, hey, I've been there. The National Aeronautics and Space Administration, in cooperation with the United States Air Force. That's, Armstrong, I think. Looks like Armstrong, at least the building does. Presents the Lockheed YF-12.
The National Aeronautics and Space Administration's Dryden Flight Research Center, Edwards Air Force Base, California.
I swear I've never seen this video before. It's just, you always know what voice is coming.
NASA's program for research into supersonic flight began at Muroc, California in the spring of 1947 with the X-1 rocket airplane. Hypersonic flight research began with the
Yeah, baby!
A great deal of information was obtained in the high-speed, high-altitude, and short-duration flight envelope with the X-series research vehicles.
Oh, yep, you broke it. Did you guys see it? Did you catch that?
Sonic flight research began with the X-15.
The X-15 likes to break right here.
A great deal of information was obtained in the high-speed, high-altitude, and short-duration flight envelope with the X-series research vehicles.
Yeah,
Sustained supersonic flight research continued with the XB-70. Having exploited the potential of these vehicles, NASA required a more advanced flight platform. To fulfill this requirement, a joint United States Air Force-NASA program was initiated using the YF-12. This program would extend NASA's capability into sustained high-altitude, high-speed flight. NASA's use of the YF-12 sought to achieve many objectives. Some of the priority programs include investigation of predictive techniques in new design for structural, stability and control, and propulsion systems. When NASA received the YF-12, significant testing had been completed, providing a ready research platform.
Can you imagine the aerodynamic research you could do if you have this at your disposal? Here, have this plane. We don't need it anymore. What? Here, have this. We don't need it. How fast does it go? Fast enough.
The YF-12 is a member of the triple sonic Blackbird family, a product of the Lockheed California Company facility.
If only NASA kept it. NASA was the only one operating SR-71s until 1999, Hellfish, if math serves me left. Yeah, NASA was the last operator of this. True story.
Known as the Kelly-Johnson Skunk Works. The YF-12 was conceived as a high-altitude, high-speed interceptor. Its basic mission,
What a
maximum
cool
range
looking
intercept
plane.
with an operational radius of over 1,000 nautical miles. The basic design concept was a low aspect ratio double delta wing with the propulsion system located in the flow field where base drag would be minimized.
Smart. Smart Ames.
Extensive use was made of existing NASA wind tunnel facilities.
Ames.
Beside the usual lift, drag, and stability testing
I want that wind tunnel model.
at low
I
and
want it.
high speed, transonic measurements were particularly critical. The thermodynamic and aerodynamic loads on a Mach 3 airplane are staggering.
Yeah, I bet. Make your own. Tessa, I'm no rocket scientist, but that looked like it was made out of titanium. That wind tunnel model. I mean, see the sheen? That looks like titanium. If that's made out of titanium, I don't want to make one of those. I don't have the money to do that. I'd have to remortgage
Loads on
my
a Mach
house.
3 airplane are staggering. The operational temperature range for the YF-12 airframe would be from a minus 65 degrees Fahrenheit to a plus 800 degrees. During cruise Mach, the leading edges and inlets run over 790 degrees Fahrenheit. Wing and fuselage 450 to 500 degrees. Afterburner and ejector between 900 and 1100 degrees.
Wow.
And the tailpipes are glowing white hot. This airplane, capable of sustaining speeds of
Maybe
over
O-force.
2,000 miles per hour, overcame a
But then again, I suppose if you're testing aerodynamic shape, it could be aluminum. It could be just aluminum or it could be steel. I mean, you're not... But then again, if you're doing wind tunnel testing, I mean, it really depends on what they were testing in the wind tunnel. If they're testing thermals in the wind tunnel, you probably want titanium. But... scale doesn't really work like that, you know? So the wind tunnel is probably for aero, and if it's aero, the shape, what you make it out doesn't really... I'm not going to say it doesn't matter because it does, but if you're testing aero, you probably could have made it out of aluminum.
giant hurdle
But that's just
in
a
the
guess.
engineering
so.
and manufacturing state of the art. Lockheed had been working with titanium on a research basis since 1949. An advanced alloy of this metal was selected to achieve the strength-weight ratios required in this hostile environment.
Well, there's that.
Full-scale mock-ups and test rigs were used extensively.
Oh, that's so cool.
A four-body section was constructed and subjected to the heat and stresses to be encountered.
Fun fact, Space Shuttle ACES flight suits, the pumpkin suits that they used on the shuttle program, are derived from the SR-71 spacesuit. Yeah, true story.
From these tests, much was learned about hydrogen embrittlement, heat treat procedures, and forming methods.
Hydrogen embrittlement? Wait. What do we... Hydrogen embrittlement refers to mechanical damage of a metal due to the penetration of hydrogen into the metal, causing loss in ductility and tensile strength. Where's the... Hydrogen can do that? Why? Dude, frick hydrogen. I mean, no, we're here because of hydrogen, but also... Hydrogen... I mean, yeah, Rocket Guy, we've often said that it can just leak through things. I didn't realize that if you did... I mean, it makes sense. If you did it at high speed, it leaks... It just goes through stuff. That's strange, man. is a reduction of ductility of a metal due to absorbed hydrogen. Hydrogen atoms are small and can permeate solid metals. Makes sense. Did the Soviets have anything like the SR-71? No. If they did, I don't know about it, Dak. Or, like, they didn't, they keep it close. The Soviet aerospace program is pretty good, but it wasn't as good as the US's was. Don't get me wrong. The Soviets made some good planes, and I'm not even going to sit here and pretend like they don't understand what they're doing. It's just, there's getting it to fly, and then there's going, like, there's getting it to fly, and then there's going after, like, really precise aerospace engineering. That's the difference between making stuff like a space shuttle and making stuff like, or an SR-71 and making stuff like a P-51 or a Lag-3, right? And don't get me wrong, I'm not saying the Soviets can't engineer stuff. I'm just saying they never really got to super precise, like super precise engineering like this. I mean, most, like, they got close. Let's say they got close because they had stuff like Buran. Buran is a hell of a piece of engineering for what it is. Even if it copies the space shuttle's aerodynamic shape, that's still really impressive. Like, I'd say they were just a smidge behind. Like, they didn't have anything like the SR-71. But then again, the ideas about how to fight the Cold War on the Soviet side were different than our ideas about how to fight the Cold War. So that does yield you different things, right? So just because the Soviets don't have something like an SR-71 I don't think it necessarily means that, that doesn't necessarily mean that they weren't it wasn't precise engineering. They have stuff like the Okreno plan, which we have nothing like that. Like the Caspian Sea Monster, that was pretty impressive for what it is. But I don't think they have... there's no equivalent that I know of that. I don't think they wanted to try and make an equivalent of it. I think they wanted to try to make a missile to shoot that thing down, and that's what they did. Weren't the Soviets the one who cracked the code for stage combustion cycle? Oxygen-rich stage combustion cycle. Yeah, they were one of the first ones to do it. Yeah, absolutely. They're, like, I guess in terms of, like, building hypersonic planes, they didn't have the precise engineering down like we did, but oxygen-rich stage combustion was frankly a genius idea. Really, really smart. Soviet engineers came up with the idea of of heating up your oxidizer before it goes into the main combustion chamber and turning your liquid oxygen into a gas. Why? Why would you do this? You do this because it's easier to atomize something that's a gas, because you can make the gas go to lower pressure and the gas spreads out. Or no, you can heat it up and it spreads out. I got it backwards. PV equals nRT. If you spread it out by heating it up and you spray fuel into it, more fuel can atomize with more oxygen. You get a much more powerful explosion. Raptors use a stage combustion cycle, full flow stage combustion. But the Soviets in the 60s, so we're talking like 50, 60 years ago, they came up with the idea of atomizing the oxygen, or not atomizing, turning it to gas before atomization. It actually makes it much, much more powerful. That was their solution to, like, the lunar program. Instead of making a bigger engine like what we did with the F-1, they made a bunch of smaller, more powerful engines. SpaceX is actually kind of going down that pathway with the 33 Raptors, for what it's worth. The Avro Air was going to be something special. Then Diefenbaker scrapped it because he was paid off by the U.S. to use the engines in the F-104. Fact. I mean, it's not, like I said, I retract that. I don't think it's because they didn't have the precise engineering. I think it's because their priorities were elsewhere. Because the way the Soviet Union thought about fighting had the Cold War gone hot was different than ours. I think that's a good way to put it. Anyway, that video was cool. We can watch more of it later, but I want to get back to working on this. Holy crap, they got close. Okay. All right. We gotta get the wings done, homies. Oh no. No, no, no. No, 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 no. Ho, 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 ho. Oh. That's scary. And guys, you know what's crazy? That's not a small plane. MD-11s are not small. They're almost as big as a 747. They're almost as big. Not, but it is a wide body. That's a big airplane, man. Yep, shorts check for sure, man. I'll tell you what, though, the pilot had good situational awareness, I would say. I mean, once again, armchair pilot. The guy knew. He saw that hill coming. You could tell when he levels off, right there. When he levels off and pulls up, right there, I'm not going to say that wasn't a little bit close, but I don't think, the pilot got, target fixation or anything. I think he saw the hill. If he didn't see the hill, he would have stayed like this to try and splash the fire suppressant over here. It's a DC-10? It's the same thing, whatever. But that's definitely a little bit of a close shave. I think the pilot got to about here and went, oh, frick, there's a hill there. Yeah, I should probably pull up. Pull up and hit the gas. And, yeah, if the guy had waited any longer to, here, that's it. You're paying on the freaking ground. It takes a second for those jets to spool. You don't have instant throttle response. I'd pay $10 to be at the top of that hill. I mean, maybe over here, not where the red stuff comes down, but yeah, I'm with you. You could definitely tell the pilot went, oh, yeah, we got to pull up. He saw it coming, though, which is good. He didn't wait too far. A lot of the things I learned this from the Blanco Lirio channel, which is a channel that reports about air accidents and stuff. I learned from Juan Brown, the guy that runs it. I don't know him, but I do watch a lot of that channel. That target fixation is something with firefighting planes that's really, really, really... It's not a problem. It's just something you gotta understand. So, okay. Anybody here ever played Battlefield? Battlefield, like Battlefield 2, Battlefield 3. You ever fly in a plane around in Battlefield and you see a guy on the ground and you try to strafe him and you're so focused on trying to strafe the guy that you actually crash the plane into him? That's target fixation. You lose situational awareness. That's hard to, I mean, I'm not saying that, fighting fires is like strafing a target, but it's close. Same idea. You can't focus on the target. You have to remember what the plane's doing and where it's going. If you don't, well, the ground comes up really fast. Yeah, target fixation, tunnel vision. Almost flew into a tree trying to land your sailplane. Yeah, you got to be careful. This is something that's really, really important when you're a pilot. You have to maintain situational awareness. You basically have to have the wherewithal to have like a third-person view of your airplane, right? Like, think about like if you're playing flight sim and you're in third-person view, you can see what your plane is doing. Now, pilots don't have that luxury, right? You can't see the outside of the plane. You can't see what the plane is doing. So you maintain situational awareness. You watch the gauges. You watch where the plane is going. You obviously, if you're flying like VFR, you watch the ground. Pay attention to the maps. Plan your flight, etc., right? Like maintaining situational awareness in a plane, and I mean this applies to spacecraft too. It really applies to spacecraft because with spacecrafts, with flying in space, you won't know you fricked up until a lot later. Usually. Right? How many hours do you have in flight sim? I don't know, Artusis. I don't know. I played flight sim for like a month straight when it came out. Like just flying planes around. I think I was flying around the Citation CJ4. What I would do in Flight Sim is I'd fly around to regional airports with the CJ4, and then once we got to like an airport, I'd get a 152 Aerobat, and we'd fly around and tour the sites, come back, land, and then take off and go somewhere else. Yeah, we did that all around North America, which is actually pretty cool. You're a bush pilot in the simulator? Yeah, that was a good time. Maybe when the new Flight Sim comes out, we'll jump back into it. But yeah, guys, like, I'm more about plane design than flying them. I mean, don't get me wrong. I'd love to get a PPL someday, but my eyes are too screwed up for that. But if I can prove that I know what I'm doing, then we should be okay. It's on my priorities list. But I know a lot about planes because I know how they go together. I really, really do like, I mean, I like the design. I like how the thing is made, you know? That makes more sense, right? Yeah, tooling around the Grand Canyon, yuck. That was fun. In that Beechcraft, man.
Discovery,
That
go and
King Air was a nice plane, at least in the game. That was a beauty to fly in the game. I've never flown one. I would imagine that it's a somewhat approximation, but yeah, Fish, there you go. Panta, 59 months. One more month until Worm Gang initiation. The stereotypical mechanic who knows every bolt but couldn't hit an apex to save his life. I am not a good race car driver, Big. I'm not a good race car driver. I will tell you that right now. My career as a sim racing driver is not the best. Alright, so let's play. Let's play with these wings. Let's see. So let's I want to attach these to the spine of the plane, right? And then, let's move them back like this and do something like this. And here, so wing tessellation, guys. If you noticed, I made two wings, right? They're two triangle wings going back to front. Now, I know what people are going to ask. Why don't you just use this? I'll show you. Using the triangles allow you to make a convex shape out of the wings. You can bend them. I'll show you in a second. I got to put this one in symmetry. So if you say, I got to actually kind of remember how to do the tessellation. I don't know if we're necessarily going to need the panel tessellator, but we'll see. Or the tessellation tool that we made, but yeah, we'll find out. So on top of it looking like really cool, kind of looks like scales. You can use this to make complicated shapes. But no, you're not bad. For how often you race, you're pretty good. I guess, Chris. I wouldn't call myself good. Let me put it to you this way. I know I can do better. Is that fair? Kind of like chainmail. Yes, precisely. So basically how wing tessellation works is that you start with a big shape like this. Or you start with a shape like this. And we might have to move these in so they're, we're gonna get some Z fighting doing that. We'll see. Alright. So, let me show you. So first of all, for our shrubbery engines, I want to make the fairings so they don't go into transparent mode. Cool. So here, let's try and make the back shape today. Now, once again, I'm not saying that this is going to be the final design, but yeah, we might be able to get close. So let's move this back here and move this one. Let's keep that one straight right there and then go from here. So if you notice, I have lines of triangular wings, right? The triangular wings are attached in a way that basically makes it so one wing is attached. The wing that's pointing this way, this one right here, this one is attached to it, and I'll tell you why in a second. That's because I need to make this wing move independently and conform to the shape that I'm trying to make. Once again, this gets a little weird and it gets a little complicated, but if you use it, if you learn to understand how to use this thing, you can make some really, really awesome wing shapes. I always like to go a little further than where my planned wing is with the shapes, so these ones can go a little bit further this way. And this is the reason why I made the shapes, why I made bucks, or just kind of a guide for where I want the wing shape to be, and kind of a profile out of I-beams, right? For where I want this all to go. Now, I will say that wing tessellation it's pretty part intense. You're gonna make a lot of parts. But it pays off if you know what you're doing. So I'm just gonna keep attaching stuff to the SRB here. We gotta flip this around like that. And yeah, like I said, it is a lot of parts, but you know, we're up over 1,000 parts right now, but these guide pieces that's made out of like thousands of these little panels, those aren't going to be there, so just keep that in mind. Why not use smooth offset? What is smooth offset, Electro? I'm not exactly sure what you're trying to say. I use absolute snap to make sure that all of these line up. If you use absolute snap, you can space each wing perfectly from the next, and it gives you a really, really smooth shape. Alright, now that I'm thinking about this, yeah, okay, I'm remembering how to do this. This needs to be attached here. We gotta attach to one wing like this. That's how I did it on the K90. And then this one needs to be attached here. Basically, I'll use one wing to basically control to the next wing, if that makes any sense. It's kind of hard to explain. It's kind of hard to explain the wing tessellation. Basically, I'm using these curves to make complicated shapes, but yeah, it's a little bit difficult to explain it without kind of visualizing it. If I'm just blabbering on and you're like, I don't know what the frick you're trying to do, man, I'll show you. Just, yeah, let me go in here and mess with this for a second and see. All right, that should be enough wings. I always add more wings than what I think I need because it's easier to add them now and kind of make a huge grid. Think about it like almost like wrapping paper. If you've ever wrapped a present, this is, you kind of blanket the entire thing and then wrap it around it. That's basically what we're gonna do, but with wings. So the first thing that I'm gonna do is I made this profile curve right here. I made it out of I-beams and robotic parts to get the shape that I want. These wings need to curve down like this. So the first wing is basically lined up. Now this second wing needs to be on a 2 degree offset. So what I'm gonna do is sit here and turn on smooth. Electro, this is where I'm turning on smooth. Yeah, I understand that. I need the absolute snap to make sure that the spacing is right, to make sure that I have a nice, clean sheet. And now we're going to move these things with smooth. Wing tessellation does take time, and you need patience. So now that I move this, now we have that lip right there. We don't want that. So what I'm going to do is, if you notice, these wings right here are basically, the top of the wing surface is kind of halfway through the I-beam. So that's where we need to go. We need to go right there. Right? Now, take this next one and literally do the same thing. Now, some of this might not line up exactly because my I-beams, I made this mistake. My I-beams are not the length of the wings, so we're going to see if it's close enough. I got to, like I said, I used to be really good at this. I got to remember how to do it. Now, this wing needs to be aligned with that beam right there. Nope, that's not exact. And then this one needs to wrap down to the bottom of the plane, or the back of the plane, the engine section, like this. Now I'm already noticing some problems here. Our engine mounts are clipping through, but don't worry, we'll fix that. So now, see, we have that concave shape, but that's not our full wing shape. That's not the whole shape. That's not how the wing goes on Star Raker. The wing kind of goes up here, and it's kind of this wing shape kind of flows air inward this way, and it's the lowest right here. So we're going to have to start contorting these wing segments around to get the right shape. So let's take this one, set it to local, and then let's try moving it up 5 degrees, like that. That's close. Right? And then take this and move this way, like that. Now, this shape only goes till about here, right? So where this kind of tilts up is basically where our control surface is, whenever we decide to make those. That's where they need to go. So I'm just going to leave that for there for now. Actually, we could probably cut the wrapping paper, so to speak, because once again, our control surfaces need to be here. And I'm going to have to find a custom solution. There's no control surface this big that's going to be useful for us. And we need 2 of them. We need a big one for pitch, and then we need elevons on the outside for roll. Kind of similar to a delta wing design from the space shuttle. It's similar. Now, what we can do is, if we want this shape to conform a little bit more, this guideline here was just there for... The guide shape is just there to give me an approximate. If we wanted to move this back and we wanted to move it down like this, yeah, we started to clip into the tanks a little bit. But if we could, tank design is still in flux, so let's move that down a tick, right? And see if we can move this up one, like that. And that will, it almost gets us our shape. Let's just see if we can play with this a little bit. Now, if you notice, I left that wing straight there. I left it like that on purpose, so we could put, when we go to put the ohms thrusters in, yeah, it'll work. Oh, I forgot to set each one of these to grandparent part. We might have to remake it, but that's okay. I'll use this time to learn. Hey, Milo. What's up, buddy? Click each one, do it. There's like 500 of them. I use grandparent strut because the grandparent struts are acting like stringer struts here to hold everything together. I'm actually noticing something. This thing isn't using typical grandparent strutting here. The grandparent strut isn't recognizing the symmetry node, and I'm not 100% sure why. I think it may have something to do with the inverse scaling here. But if I'm talking gibberish, just bear with me. So sometimes if you have robotics in line on your mainline hierarchy, which is inevitable on this design, it screws up symmetry nodes because of inverse scaling. If we open up the debug editor here, there's yellow text that shows up. Box colliders do not support negative scale or size. This happens when you attach stuff to robotics. Yeah, we figured that out when we did the Mark V shuttle build. And it seems like it's not generating the grandparent symmetry node, but... I mean, Hokie, you wanted this. And lag in the game made me misclick. Bye-bye. I'll just remake it. It's literally quicker. Before you get too far into the tessellation, I'd probably recommend using the standard rectangle AV panels in the section that it's flat on the top there. Save a couple dozen parts when you can. Tessa, the problem with that is that it looks horrible if you have flat panels next to tessellated panels. It looks awful. But we might not have a choice in this regard, so who knows? We'll see. We're gonna have to go and sculpt again, but yeah, you see with the panel tessellation. Yeah, I mean, honestly, Tessa, I'm probably gonna give this a couple of goes. I'm probably gonna have 2 or 3 goes at this, just because I gotta remember how to do it. There is a method to building it, and I think I know it, but yeah, if I have to prototype this shape 2 or 3 times, I'm not too worried about it. I think what I'm really missing this time around is building in more guides that go this way instead of just left to right. But yeah, we'll see. Hey, Barris. Now these should all be grandparent strutted. Okay, cool. So now we're gonna go and do this again. Now this requires a little bit of a steady hand here to use the smooth snap. Cool trick. If you're trying to get really precise rotation, there's a couple of ways that you can do it. But I find that if you click on this, the rotation, right, and you move the mouse further away from the point of rotation right here. And this is a really awesome piece that Felipe put in, if I do say so myself. This is when Harv added gizmos. If you move further away, you get finer control over things. So let's move this down like this. Let's see. Is that parallel to anything? No, we need to be parallel to this I-beam, to this set right here. Because your arc is larger. Yeah. Mm-hmm. Yep. Alright, we don't need the back. We cut that off. Like I said, wrapping paper. Alright. Look at that. That's already looking like the back of Star Raker. It's definitely getting close. If we go up here. It's already getting there. Hey, Zeman. Alright, so now we're going to do exactly what we did before. We're going to try and sculpt based off of my measurements that I have here. So 5 degrees is probably not exactly right, but 5 degrees right there is enough to get up and over all of my engine mounts. And don't get me wrong, the engine, I mean, well, I was going to say the engine mounts are in flux, but our shrubbery engines here are, yes, I call them shrubbery engines. They're, yeah, that's pretty much what we want. Yeah, that's pretty much where the motor mounts are going to go. I'm using these beams right here, the girder segments, as a way to mount the engines. And then this is going to need to go flat like that right there. And then that gives us something to kind of tee off on. And then we can basically cut the rest of this out. Like I said, that's where the control surface is going to end up. And yeah, control surface is going to be definitely a weird shape. So let's, I'm thinking. Well, here's the thing. This shape flattens. It's kind of helical. As the back side goes this way, the front side goes that way. So we're going to have to make something that kind of curves like that. So here's how you start to do this. So that piece is tilted up just a little bit, just a smidge, right? And we kind of have to make a curve here that goes from here to here. Because we have to conform to this shape. So here's what we do. Let's take this one. We can start at the back and work our way forward, right? So tilt that thing forward now, right? Tilt this thing a little bit forward, like this. And move it down just a smidge. Nope. Well, that might be a little bit too much because of the motor mount, but tilting it and rotating it moved it back in line, so it's making a straight line. But now we have that right there. So here's how you get around this. You take this wing right here, and you move it so it's parallel with this wing, right? And then you move it down like this, and then if you're on local, you could just rotate it right into position. See? And now we filled that gap. Now we made a concave shape in this kind of regard, I suppose. I don't necessarily want that. That might be a little too much. So let's mess with the curves just a little bit. That looks to be about right. So now, move this piece up, and then this is where the steady hand comes in, because you got to make sure that's more or less parallel. You don't generally want to move this thing forward and back. That can screw up the shape. You just want to use rotate and up and down. Rotate this way, so that would be rotating it like this, and then up and down. Don't move it forward, don't move it back. It'll screw you up later. Hey, Nagwal. Alright, so now we move this up and down and we rotate it, right? And now this one's out of whack. Now, don't necessarily worry about lining it up with this over here. Line it up with the shape, with the wing that we already have. So, first thing you do, actually, you got to rotate this one this way too. Rotate this way, get it parallel. Don't translate forward, back, left, or right. Just move it down. It's not exactly parallel. And now get it lined up with this piece. Now don't get me wrong, sometimes you're going to get a seam here. It's not going to be always as kind of seamless as this. You're going to get a little bit of a weird shape. But, once again, look at this row only. I mean, there's obviously a big seam right there. But see, it lines the shape up. Hey, Ryan. John, does that count? That would be the second time today. Now see, this next one, we're going to need to rotate this way because we're trying to even that shape out, but we want the back edge to stay the same. So, do you use part welder? No, I don't like part welder. It ruins the fidelity of flying around your ship. Like, if you weld parts together aerodynamically, it's not going to work the same. No, I'm being super sarcastic. Please don't count it. Yeah, I got you, man. I got you. I was just busting your balls a little bit. Alright, now move this down. Make sure, once again, you gotta kind of eyeball it. Now we're making the shape that we want. Now we take this piece and we rotate it a little bit more. Move this down into position. Make sure that's all flush. Right? Making sure that's flush. And then take this control piece. Make sure that it's parallel. Actually, I'm already thinking about ways I could save steps with doing this. And yes, we could use a tessellator. You're missing 2 small engines and a rudder underneath the box. Yeah, the ohms engines. I'm gonna make that box as a separate sub-assembly, dude. The orbiter maneuvering engines, yeah, it's gonna be a different piece. The beauty of this is that I can cut sections out and we could just attach this right there and then gizmo it into place. Yeah, I basically wrap the gift first and then anything that's on the outsides of the wings we kind of add later. Honestly, I'm actually thinking about ways to make the panel tessellator work way better. But we'll get to that later. Now this one, maybe I want it to be angled down a little bit to kind of more match the edge. Yeah, it looks like that's what I did there as well. Love how it's coming along. Thanks, man. Now with this, we're going to need to tilt it down a little bit. We should make a wing tessellator. I've decided. I don't know about this design. You're gonna need an awful lot of duct tape. Yep. But yeah, this cat up here, it's going to be its own sub-assembly. But yeah, the engines, I shouldn't attach them to the wings like that. But the two engines are going to be around here. And this part, I'm not even going to bother trying to sculpt that into the main shape. Because they wouldn't, that's not how they would do it in real life. Like if you were making something like a box that's attached to the top of this, right? And you needed these two engines to be there. Let me show you. Go in here like this, just get rid of those covers and say, like, that's how we want our engines to be, which is basically like the real one. You do this. Ready? This is just an example. This isn't the final shape. It's nowhere close. See what I'm talking about? Now, that might mean we can get rid of this later, but it's really hard to kind of plan that out, which is why I like sculpting the wing shape first. We could probably get rid of these down the road, but yeah, you get the idea. And that actually might be a little bit too big. The piece looks more like that. And then for these pieces, we could probably get away with using these. Like that. See what I'm talking about? But yeah, that's just an example. I like sculpting the wing first. But if you have the foresight to be able to see what that thing looks like before you build it, yeah, by all means. Now, let's see, we gotta mess with our engine mounts. Because our engine mounts, especially on the outside here, are clipping badly. I'm wondering if we could... Yeah, you could just gizmo them down a little bit. Just make sure you're on local when you do it. 1, 2. You were an absolute? I don't think I was I? When you raised the first one, I was gonna say, is that... Hey, why is there a battery right there? Oh, I made the sub... Alright, we don't need those. The engines don't need their own batteries. We gotta modify the sub-assembly for the engine. It does not need those. That's extra parts. I put that battery there for when we were test flying the motors. You saw the snap? Alright. Okay. What are you doing? Get out of here. Alright, I'll just redo it. Let me just measure the distance here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, 13, 14, 15, 16, 17, 18, 12, 13, 14, 15, 16, 17, 18, 19. There we go. Cool. I'll probably redo the motor mount design here. I'll just leave those there for now. They do need to be redone a little ways. All right, so I'm gonna cut this piece off right there. That's it. Good. Now, the next piece. Right? So this is actually going to be part of the wing, because right there is going to be control surface. There's going to be elevons right here, right? Thanks, Pato. Appreciate it, man. Yeah, she's coming. And I can actually, when we go to build the ohms cluster, we can actually take this thing and move it on absolute inwards to get that edge to line up there. And we could clip a couple of wings in right there, and it won't be that big of a deal. Hey, King Kitten. What's a funny fact that involves the number 88? I was born in 1988. Does that help? I'll take it. All right, sounds good, man. That's not a funny fact. Oh, alright. Sorry. 88 miles an hour. Michael Jackson performed at Wembley Stadium in 1988. Does that count? Yeah, sure. Alright. So, yeah, see, I did it backwards, dudes. Now starting here is going to rotate the entire wing. You have to go from this way back. Fudge. Because now if I try to move this into position, that's not going to work. It'll just bend that out of position. And yeah, trying to eyeball lining that up again is going to suck. So, got to start over. That's okay. I got to remember how to do it. I have to remember how to do this, so... Bye-bye. If at first you don't succeed. It's okay. Once I remember how to do all this correctly and not like a schmuck, we'll be good. When will you learn? Your actions have consequences. It's gonna take a second to do this, right? But I was actually thinking you could do a panel tessellator. I could make a tessellator tool with this. It's doable. Grab. I don't know. I have no idea what you mean. Grab Shark, it's 2023. I can think whatever I want, and I can, if I can think that actions have consequence. Wait, what are my values? All right, so we know we're not going to need this shape here, so we can get rid of that. Okay, so let's start up here. And now I have the buck shapes here to, like those panel guides, to kind of help me conform the wing shape correctly. Now, Tessa, like you were saying, that's pretty flat all the way to here. We might not need tessellation there because it is flat, but We'll get this. We'll get to that. What I'll do is I'll leave, for now, I'll leave one of these right here on an absolute snap, and I could sub panels in later. Check this out. It looks insane. RC airfoil. It uses ground effect. Yeah. Yeah, that's cool. Flakin. Yeah, ground effect. I've seen this video before. Here, I got another one for you if you want. There's a YouTuber called Peter Sripple, and he makes, I'm not sure if I'm saying his name right. Peter makes all kinds of planes. Check this out. I don't want to watch all video. You guys should check the video out. But
malleable aluminum flashing tape flying around a lot. So yeah.
watch this. Cool, huh? You guys have probably heard this music on my stream before. This is where I found this song from. Cool, huh? That's actually really neat. That's a really awesome model. He did a good job. Here, I'll link this video in chat, Flacken. But I've seen that video, and I've seen, yeah. If you want more, this is, yeah, watch Peter. He's really good. Yeah, it's pretty awesome. Yeah, see, I'm not 100% sure how we're going to do, this part of the wing, but no, we listened to that already. We listened to that already. We listened to Run Tonight already. Here we go. It did say yeet, yes. Mm-hmm. Alright, so we'll leave that one there because that one's going to be flat, and then we'll start sculpting the front of the wing here as best we can. I mean, that one's... yeah, this is not going to work exactly how we want. I might need to switch to a smaller wing to get this part of the shape.
Discovery, go and throttle up.
Sneaky! Now hold the front door. You're trying the Mega SSTO again. Star Raker? That's the project that I've been working on, yeah. I wanted a nice big KSP project to work on. I'm once again trying to make SSTOs. So is this plane going to use the same engine as the Blackbird? No. Starliner press conference live with your favorite hold music. Oh, no way. The presser is live, yeah. How did the Sunday launch go? I ended up missing it too, Tigris. I had some personal stuff that I had to take care of, kind of a little family emergency. Everything's good though. Everything's cool. Yeah, the wing leading edges are going to be difficult to make right. Yeah, it's cool, Flacken.
Good afternoon, everyone.
Okay, that presser's starting, guys. We'll work on more wing tessellation on the other side of Space News, okay?
Spacecraft Update Telecon as part of NASA's Commercial Crew Program. Starliner will launch NASA astronauts Anita Williams and Butch Wilmore on its crewed flight test to the International Space Station ahead of future operational crewed missions. To discuss the spacecraft and planning today with us, we have Steve Sitch, manager of NASA's Commercial Crew Program, Mark Nappy, Vice President and
I
Program
wanted to listen
Manager
to this.
for
This is
CST
important.
100 Starliner at Boeing, and Joel Montalbano, Manager of NASA's International Space Station Program. As always, if you're joining us on the line and you have a question, please press star 1 to raise your hand and star 2 to lower it if your question has been answered, and we'll get to that portion later in the call. First, we'll start out with some opening remarks, and I'll turn it over to Steve.
Yeah, thanks, Leah, and thanks for all the interest